Hello viewers, welcome back to video tutorial on AgentGrid. This is the fifth video in this tutorial series. In the earlier video, the first video, we were discussing about what is AgentGrid and its capabilities and organizational other projects of organization. And also in the first video, we had discussed about sequential pattern. And the second video, we have discussed about conditional sequence pattern. And the third video is about parallel pattern. And the fourth video, we discussed about a router pattern. So in this video, we'll be discussing about a orchestrator pattern. So the tutorial orchestrator agentic pattern with open source agent SDK. So in this tutorial, we'll demonstrate how to build an orchestrator agentic pipeline using our open source agentic grid SDK. And as we generally explain with an example, in this current tutorial, we'll be using an universal marketing campaign flow where orchestrator dynamically plans and executes the localized marketing strategies across multiple regions. So the links you can click on these links to understand more details about AgentGrid and its documentation, and these links you can use to understand the agentic patterns, videos, and blogs related to agentic pattern. So all this we have explained in other earlier videos, so I'll not explain it again. So a universal marketing campaign with the orchestrator pattern. So the orchestrator pattern uses a central agent to break down complex goals into a structured set of tasks. So you are having an orchestrator here or a supervisor who you are giving a task to it. It will take care of breaking the task and delivering it into several other sub-agents, and also to get response from those sub-agents, and then aggregate all the results and send the final output to the user. So this is what the whole flow would be. So the pipeline stages a strategic planning. The orchestrator analyzes the product and target market to design a custom pipeline. So here is the orchestrator. It will analyze the product given in the user input, and also the target markets in the given input, and design the custom pipelines. And we have an sub-agent known as content generation agent. The content creator produces localized campaigning copy, meaning let's say you want to generate something for Japan. So for Japan, what needs to be for a given input, what needs to be content needs to be created. So this content creator agent will generate that. Visual creation, this is basically an image generation agent, the second agent here. This image generator uses a Google Gemini Imagen APIs to create the assets and store them in a Minio. So whatever the content it has created, for the content creator, it has to give some descriptions about image generation as well. So with that help, it will try to generate a image, and right now we'll be generating only one image, and with that image we'll be will be pushing that image to a Minio so that it can be shared to the user at the end. And we'll be using right now Google Gemini APIs. And next, brand review or agentic retry. So basically the third agent, what it does is it takes this content creations and as well as the image generation output, and it will try to check whether the image is adhering to the content creators content requires content. So content creators content. So basically it will review it. If the review is not good, if the score is low, then again it will ask for a retry. So in the retry, again a new image is generated and given to the review. So right now you can keep on looping it, but we are just stopping it maybe at 1 or 2 iterations, and after 1 or 2 iterations, whatever is the finalized image is there, right? So that will be used as a image for the task. So next is a social strategy. It's a social media manager. This defines the target audience and the distribution channel, like what needs to be done for a social media campaign. So this agent will decide it, like the age group, gender, location where it needs to be published, etc, and timings. All those will be decided by the social media manager. So the orchestrator here, basically given a task, it will break down, it will identify what all agents I have for this task, and based on those agents it will allocate the task. It will generate the pipeline first. Pipeline in the sense, let's say for a Japan, people are not interested in images, so it will not maybe choose this image generator agent. Or for Japanese language is important, so then the content creator will take care of that important, like, okay, we need to generate the content related to Japan only in Japanese language. So the orchestrator will help, first of all, breaking the task, dividing, giving the task to the individual agents, and picking the result from them, and then aggregate it, and then finally send it to the user. So this, we can say it as an orchestrator as well as a supervisor. Supervisor also somewhat looks similar to this only, so where it will take care of finally delivering the content to the user. So Orchestrator agent, it acts like a planner which decomposes the product description into a regional campaigns and a sequential a sequence of agents. So next, the content creator, it transforms the core description into an culturally items for a specific regions. Image generator generates a creative asset, which is an image from description, and uploads to Minio. And image reviewer, which acts like a consultant, which audits the image for a cultural alignment and triggers a retries if quality threshold or score is less than 80% or so. And then a social media campaigner, basically it like acts like a strategist, defines demographics, platform specific engagements, and optimal posting schedules. So these are the four sub agents and the one orchestrator agent. The codes are provided, the links are provided here. So let me just start explaining one by one. So the first is the orchestrator agent. So it has some pydantic classes, which is meant for, one is for pipeline and one is for a full flow. So here pipeline, it has one name and it has an agent ID and a tasks instruction. So some instruction is required, what is this will do. So such kind of output is required. So this is then one pydantic based model. And one other pydantic based model which has a market name, which is a name of the market, let's say Japan, and the pipeline. So this engulfs a list of the pipeline stage plan, whatever class is here, right? So that list is a is nothing but the pipeline. So list of this list of pipeline stage plan is what pipeline is. So we have an orchestrator signature, which is a DSPy signature. Whatever the content you are seeing here, it will be same as our JSON file. Let me just open the JSON file. Yeah, this is the image generator. So this is an orchestrator JSON file. So we have a default message here. So this content would be same as the whatever the content we have here. So I'm just showing it so that I don't have to again open the JSON file. So here we are defining the system message for it. Basically, you are a strategic marketing orchestrator, So decompose the product description into localized campaigns for each target market. So we have to provide a product description, and we need to provide the market details as well. So then it will take care of decomposing that into a localized campaigns for each target market. Identify the most effective sequence of agents from available agents list to fulfill the campaign goals. So right now I'm just giving examples of 4 sub agents. Let's say you have some other agents like mailing agent or some other sub agents are there, right? So if they are related to marketing, so this orchestrator has to identify who all are there, first of all, in the marketing platform, marketing task, what all agents are there. It has to identify those agents, and based on the availability of those agents, it has to decide the pipeline as well. So workflow construction rules, we have given some rules. Analyze the capabilities, rate capabilities, inputs, outputs for each agent in available agent. So I'll just show you what is this from maybe here. Yeah, so this is our image generator agent JSON. So in the metadata, subject metadata field, there is a capabilities metadata. It has a description, inputs and outputs. So inputs, we are saying like visual suggestions is required, campaign overview field is required, market name is required, and it will provide an image URL and visual concept details. So these are the 2 things it will provide, and these are the 3 inputs it requires. So this data is read by this is aggregated for all the marketing agents, and then it will be given to the orchestrator, and then the orchestrator will understand, okay, what all agents are there, what all input it requires, and what output it provides. Based on that, it has to understand, it has to design the flow. So design the logical flow, create a pipeline where each agent's output provides the necessary context or input for a subsequent agent. So this orchestrator has to take care of that. Efficiency, if an agent content creator already produces a specific output, like visual suggestions. Do not plan a redundant intermediate stage to generate the same information again. So it's just the instruction. Product consistency. Every stage's task instruction must explicitly tell the agent to use the exact product name from the product description. Prohibit agent from inventing, localizing, hallucinating a different product name. So sometime the product one, the agent one will decide some name, and possibly that this agent two also can decide its own name. So we are just asking not to mention that in each agent's task. We are asking not to reinvent the same same names, similar names, or any new thing. So adapt to available tools. Use only agents provided. If an agent with specific capability, example image review, is available, use it at the appropriate stage to ensure quality. No set sequence. Do not follow fixed sequence. We are asking it to be dynamic. Complete campaign. Ensure pipeline covers everything from localized creation to distribution strategy. So basically this orchestrator, what we are expecting is it has to provide a list of objects, and in the each object should give a market and the pipeline. So let's say we are asking for something for Japan or India or US. So for each country it has to provide 3 objects, and each object in that the keys are market, and this is the market name, and the pipeline, what needs to be done for each market. So that sub-agents flow has to be available in this pipeline. So here is a stage name. It could be like content creation, it could be image generation, image review, etc., and agent ID. So whenever we are registering the agents, we'll register them with an agent ID here. Like say identity, there's a subject ID. This is what the agent ID is. So this is required in this particular field, and an instruction to the each agents. So this also has to be generated by the orchestrator agent. So input is product description, input field, available agents, input field, and a workflow plan, which is a list of market workflow. So the market workflow class is here. So it's a market and a pipeline. Then let me go for a DSPy module. In the init, we are generating a DS chain. We are using a chain of thought function from the DSPy module. So we are calling it as a planner, and we are giving a signature here, and the signature is, we are not taking directly this signature whatever is available here, but we are reading it from the system message, which is system message that is registered in the JSON file. And we have a parser. It is not being used that much because it is just a fallback if in case the planner is not providing a proper output. So we whatever the output it is providing, we are just trying to do a parsing. Then we have a forward function. So forward function basically does an inference. So self planner, it is giving, we are giving a product description and available agents, and it will give a plan. So if a plan is like we are taking the raw output from the plan, and we are trying to check whether it is a list. If it is a list, we are trying to get the final list from it. And if this final list is not available, then only we are trying to use the self.parser to parse it manually. So we are trying to take the raw text, and we are trying to do some parsing here. So this is not being used because we know that it will provide a proper list only. Next, agent payload. It is just like it will break the given input, what all things are required. It will just break those, and it will provide it will return those the input content. And a model context manager, which will provide you a context for the DSPy to be running using a LLM model. So pipeline executor, which I'll explain later. Okay, so let's go to a sample agent. So we, here subject and context will be given initialization, and we are trying to exploit, we are trying to extract personas like default system message from the subject. Subject is basically the registration content. You will have it in self.subject, and self.context will have whatever dynamic things required by the housekeeping stuffs required by the agent, be it communication channels or anything related to AgentGrid. It will be available in the self context. So DSP AI voice DSP LM. So this we have explained in the previous video. This basically is a class which will take care of converting your communication to the either AI voice LLMs or a third party like Gemini or OpenAI LLMs. So now we are creating a marketing orchestrator from this marketing orchestrator class, which I explained earlier. So this is the marketing orchestrator. Yeah, this is the marketing orchestrator class. So from that I'm creating an object, and also I have a pipeline executor class which I have not explained. I'll explain it later, and a payload processor for processing the input payload, and a model context manager, and known agent. So this we have used in the previous video as well, where it will try to provide us what it will help us in identifying and collecting all the agents that we want. Like say you want an agent, right now I'm creating a known agents object and I'm adding a query to it, query and add. So the query is basically I'm looking for metadata.subject search tag equal to marketing. So whichever agents are there which has a tag known as marketing, I'm trying to pull all those agents in the self.known agents. So I'll just show you in the registration file. So we have a subject metadata, subject search tag. So if there is a marketing name in that, it's an array. Tags subject search tag is an array. So you can give a marketing, a lot of tags you can provide. So in that, if anyone is having a marketing, then that tag is those agents are pulled and given as a known agents. So here there is a function known as get available agents context. So what it does is basically it will try to pull all the known agents and list all, will give you all the known agents. The query will run and it will provide you the agents of marketing agent. And if the marketing agent is orchestrator, I'm just continuing it because orchestrator is not required from this. I require all the other sub agents, right? So I don't require orchestrator. So that's why I'm doing a continue operation here. And from that all the sub agents I'm trying to extract metadata and capabilities. That is the ultimate capability metadata I'm trying to extract for all the agents, and I'm creating a kind of a array for each of the agents, and I'm just appending it in agents, and that I'm returning here in this function. So this will be used because we need to provide all the known agents to our marketing orchestrator. We need to give her the input as well as the all the known agents we need to provide it to marketing orchestrator. So that's where this function will be used. So there is no muxer required. So let me directly go to on data. So on data, as soon as a task comes, it will call the self prepare inputs. What it does is it simply breaks the it will call the payload processor to process the agent task class, and it will return a few items like text, session ID, communication type, model name, and I'll try to get all the available agents. So available agents context will be queried. So I have the array of all the agents now, and then I will give it to a executor worker. So what executor worker does is it will try to take the context from the self model context, get context, it will give the model name, and model will be chosen. So let me just show you what was the model that we have selected for orchestrator. For orchestrator, it will be integrations models. So we are choosing an VLLM based our AI voice based Qwen 3 1.7b, which is a very 1.7 billion parameter Qwen 3 model, and it is hosted under AI OS, and it is using a VLLM backend for serving. So that model is chosen for this particular task because the model name is, that's what we are giving in our communication, and that model will be selected, and it will do a forward function, a forward operation of the marketing orchestrator, which requires a product description, that is user input, and the all available agent, which is nothing but agents context that we collected from this particular function. So this executor will provide you the workflow. That's what our expectation is. It basically has to provide a array of objects, where object is meant for each object is meant for each market, and that workflow, if it is not available, we are just returning it. If workflow is available, we'll do a running of the workflow. So since workflow can be an array, let's say if I give a multiple markets, so I'll get a workflow for a multiple market. So I'm trying to do a parallelization using Python threads. So there is no since why I'm using thread is the tasks are not so compute intensive, so they just have to deliver the task to some other agents, right? So that's why I'm using a threading here. So basically I'll iterate through each workflows, and I'm creating a threading.thread. I'm calling a target as a pipeline executor.execute function, and I'm giving the inputs as task, workflow, text, and result date. So this function, let us check now. And at the end, the thread will be started, and it will be in the threads.append. We are updating this threads variable with all the threads that we have started, and at the end we are trying to join. Basically we start all the threads. Let's say if 3 workflows are there, 3 threads are started in parallel, and we are waiting until all the three threads are done with their task, and then we are giving one resulting date, and this resulting date at the end, once it's over, right, once all the threads are over, we are trying to collect it, and we'll send it as a response from the orchestrator. So now we'll just check what is there in the pipeline executor.execute function. So we have a pipeline executor, which is coming from this pipeline executor class. So here we have a pipeline executor. So what it does is basically, let's go to the execute function. So it requires a task, workflows, text, and a resulting dict key, resulting dict as parameters. So this is the final dict that we need to return. So market name, from the workflow we have it will check for a market key, and it requires a market name. So let's say we have 3 markets. So for each market, this function will be called. So for let's say Japan market, I got the market name as Japan, and what all pipelines are available is, as it's a pipeline is an array, so a pipeline will be available here. We'll get it from the workflow, and then this is the final output. It's a dictionary, like what is the market, review history and retry counts will be available here, market output. So let's go now to directly the loop. So as I told, we'll be doing an retry operation for only the image generation time. So image generation, if it is not good, we'll do a retry operation, right? So for that reason, we have an loop here, while loop. So now let's start with I equal to 0, and the length of pipeline. Let's say if pipeline is having 4 sub agents, so for this loop has to run 4 times. If at all retry is required, this loop will run 5 times, because we'll update this we'll take care of I handling whenever a retry is required, so that this loop will run again for the image generation. So the stage, we are trying to take the pipeline of I, which is we will get a stage. From the stage, we'll get to know stage name, agent ID, task instruction. So these are the 3 things that we have defined in the top. So a stage name, agent ID, task instruction. Yeah, so those 3 things are collected, and then if it is an image generator, if the current pipeline is an image generator, let's say first is a content creator, right? So it is not an image generator, so this will be false all the time. But whenever this runs for the second time, if it is an image generator, then it will become true. And also we have a review stage. If that is a review agent, then is review also will be true. So based on this, we will do rest of the things, meaning like looping and all, controlling of the loop, right? So retrying and all, we'll use these variables to take care of the controls. So if is generator stage, which is nothing but image generation, and no pending feedback, meaning there is no feedback. So why this variable is used is, whenever reviewer gives something, like say the score is not good, reviewer will will update this pending feedback, because initially pending feedback is none. So whenever one review happens, if any feedback is there, then it will be set by the reviewer's output. So if it is not, then we'll say last output. The last output currently it is no, it is not available right now. So then last output before images, whatever the last output. Yeah, the last output is the user input itself. So we are setting this to a user input only right now. So payload, so prepare stage by payload. So we are giving market name, instruction, last output, market output, text, and the last output before image, and pending feedback. We'll provide all this, and this will prepare this function will prepare a payload. So let's just see this function. prepare a payload. So it creates one dictionary where some keys are there: market, text, previous stage output, pipeline context, product description, session ID, communication. Though these two are not required, but these all are very important keys here. And if you are providing any feedback, right, so those feedbacks also will be added. If they are not provided, then we'll not add these two keys. So it has a previous stage output and review feedback. So this uh, this review feedback variables or keys are very important, because when I'm explaining the image generation, so those keys are used. We are explicitly mentioning it. If you have any feedback, then they work accordingly. That's what we'll mention in the image generation. So this prepare stage payload will provide you a dictionary. So that will go, that payload will be using it for with that payload we'll be sending it to the sub agents. So sub agents, we are trying to do a send and wait sync, meaning you will send it and you will wait for the output to come, because the though the market will run parallelly for three markets, but this pipeline has to run one after the other, because that we cannot parallelize it, because content creator has to generate first, then image generation has to happen, then it has to go for a review. So since they all are serialized, so you have to wait for the output to come from the sub agent. So that's why we are using a send and wait sync. So here we are using a P2P manager, not direct or any other delegate methods. And also if it is a generation, we are just updating this variable as last image stage index equal to I. We are just keeping this, we are initializing this variable with I, so that if retry is required, right, so this I'll just update this to again back to the I, so that retry will happen without breaking this while loop. So you got the output, and with that output we are trying to pass the output. And if it is a generator stage, so we are just creating an encourage image data, stage name, instruction text. And since the generated output will have an image URL, we'll append the image URL as well. And if it is a reviewer, it is only for a image generation. If it is a reviewer stage, what it does is it will just append the reviewer stage name and review data, whatever the review data are there, right, it will add it here. And then we have a pass review score. So whatever the final text context that we have, which is nothing but the output of the previous stage, from that we'll try to parse it. And this parser will do just it will provide only two outputs, one is score and a feedback. So score, if it is less than 8, which is 80%, and max image retries is greater than 0. So this is a variable which we have started with max image retries, which we have started with 1, and will, as soon as one image generation is over, we'll subtract this by 1. So if it is still greater than 0, right, so we are then if score is less than 8 and it is also retries maximum threshold is also not reached, number of maximum thresholds is also not reached for retries, then we will do a review operation. If not, we'll simply send pending feedback to none. And this is again some checks whether is there any image output or not. So such kind of checks is happening here. And we are trying to get the review history and retry counts. We are incrementing the retry count to +1, and then we are updating a pending feedback variable to a feedback that we have got from the agent, review agent. And then max image retries -1 we are doing it. And then we are re-updating the I variable so that retry can happen, because score is less than 8, retry has to happen. So that's why I'm updating I. I'm not incrementing I. I'm just keeping the I to the previous value itself, and then I'm doing a continue operation so that it will not go to this loop, this piece of code. So because of continue, again since a review has to happen, again it can come back to the review, and again it will do a image generation, and image review will happen. So as soon as this becomes 0, right, or this becomes 0, this condition will break. So pending feedback will be none, and I plus win will happen. Again loop will go for the next, meaning one more review will not happen. Then we are just updating the result date, and then we are passing that result date. So this is the main functions of the this pipeline executor. Basically it will call individual subagents, and when it is calling, it will call one after the other. And if a review is required because of score is less, it will do a retry again until the maximum number of retries are over. and once it is done, it will update the final global variable. So that's what this orchestrator does. Right now you can, you can go ahead and improve it, like say if you want to parameterize any of the variable, that you can do it. So let us go for a marketing content creator. So we have a signature here, content create signature, DSP signature. You are a specialized marketing localization expert. Your task is to transform a core product description into a high performing campaign for a specific market. Use the market, tailor all the cultural references, idioms and values to the specific nation or region provided. Apply the strategy. So respect constraints, synthesize, emphasize product, ensure visual suggestions explicitly include the main product described in product description. Do not just suggest abstract concepts or surroundings. The product itself must be a central element of the suggested imagery. These are certain instructions that we are giving. Output expectation, output only the final campaign content, do not include internal reasonings. All campaign copy, title, tagline, overview, etc. must be in a primary language of the target market. So we are just saying, if you are doing something for a Japan, so keep it in a Japanese language. If you are doing something for any other country which has a different language, not English, so keep the content with respect to that country. So you must follow this exact structure. So we are expecting it from product name, tagline, campaign review, call to action, visual suggestion. These are the expected fields. So given an input product description, given a market, given a strategy and constraint, it has to given a variable known as adapted campaign, which is an output field. So the final localized marketing campaign, which should contain all this product name, tagline, campaign overview, call to action, visual suggestions. This variable contains this particular output. So content parser, so basically when the output comes to us, it will not be a JSON serialized, it will be like a MD kind of file. So we are just trying to do a parsing operation using a RE package. So content creator worker, so we are creating a DSP module content creator worker. We are using again chain of thought, DSP chain of thought, and parser, content parser as a fallback parser. And in the forward operation, we are giving a product description, we are giving a market, and we are giving a strategy as an input, and we are giving a constraint as an input, and the resulting will be a adapted campaign. So these are just input parsing, model context. Then we are the sample agent class, which has a worker, which is basically a content creator worker. And in the current content creator worker, it's a very basic thing, like you given a task, you just break it into a brief and strategy. This payload processor prepare payload, right? So it will basically provide you two things, so a brief and a product description. So if previous stage output is key is present, then it will again get copied into product description key, and that will be sent as a return. So a brief and a strategy, two things are required. So those brief and strategies are sent to the execute worker. What execute worker will do, it will send the from the brief, it will give the product description. Product descriptions are required, so from the brief the product descriptions will be sent, and from the brief there is a market information as well that will be sent, and the strategy is separately. And if any constraints are present from previous the orchestrator, so that also will be sent as a constraint. So that's it. The agent, this agent will return after the talking. The LLM will churn out the data and it will provide the output, and that will be passed on to the caller, which is nothing but the orchestrator. And the third agent is a image generator. So image generator, we are right now using Gemini, Google Gemini APIs, and we are using a Google Gen AI package. Because the DSP currently it will not be able to generate any images, but it will not be able to generate images, but it can use images to do something, meaning like you want to do a multimodal reasoning of let's say given image and a text, you want to do multimodal reasoning, that it will help, but generation of image it will not help. So that's why we are doing directly Gen AI APIs. So Gen AI APIs, basically it will, whenever this function is called, right, generate image byte, you have to provide a prompt. It will provide, since the model is a Google colon is given, so it will use that particular model. You need to provide your API keys, and it will generate the image, and that image will be returned from this function. If we have a mini upload, it will just upload the image URL. It we have to give a bucket name and details. So those things are hard coded in the top. So access key, everything is hard coded in the top, so that will be used here. And agent payload processor, model context, these all are already covered. So a prompt extractor, Google image generator, mini uploader, and a agent payload. So here there is no DSPy related things, they are not available here. So you will try to extract the inputs, and you will try to extract market and visual suggestions and final prompt from this prepare data. So from the data, right? So prepare prompt, what it does is basically it will try to collect each and every data, because this data would have come from the orchestrator. So it will try to get the pipeline context, it will try to get the market, and it will try to get the content of the previous stage output. And if any review feedback is available, so if it is available, it will use that. If not, it will be an empty value. So that will be sent for a there is a builder here, prompt extractor, build final prompt. So the prompt extractor, there is a class in the top, prompt extractor. So build final prompt. So we have two functions, extract visual suggestions, extract campaign overview. So these functions are utilized in the here you can see visual suggestions, campaign overview, because the output that we get from the content creator is not a JSON, it is a MD kind of a content, so MD file kind of content. So from that we have to parse it. So that's why we are using the parsing, using again using the RE package. So we are trying to extract the visual suggestions, campaign overviews from the prompt extractor class. And then we'll use the image gen API to generate the data bytes. And then if the image URL is a data byte is not empty, then we are uploading it to a Vimeo, and then we are returning that those image URLs and visual concept details and text to the caller. So this will go to the orchestrator. After that it will go to the reviewer. If reviewer is not happy with the image content and the image the content of the image, then again it will ask for a regeneration. So now let's go to the image reviewer. Image reviewer, we are using a DSPy. So why? As I told, it's a multi-model can DSPy can handle the multi-model, meaning you can give the image, you can give the prompt, then you can ask whether it is whatever you want to do with the prompt, right? So that you can play with. So multi-model thing, DSPy will handle. So role, you are a brand cultural consultant. Your task is to review the proposed image concept and campaign content to ensure that you are currently appropriate for the target market, aligned perfectly with the brand's localized strategy. So image mandatory, you must have a valid image. So review the cultural sensitivity and potential tabos, alignment, feedback, so output extraction. So again, the output should be cultural alignment score, review feedback, and approval status. So these are again kind of a MD file kind of output. So not an MD file. We are asking explicit variables. We are asking, so it has to give these values to us. Cultural score, a score from 1 to 10 in the format of X by 10. A review feedback and a approval status. So yeah, so we are asking for a prefix as well. So with this prefix, it has to come as a output, so that we can use these variables for a RE text parsing. So image reviewer DSPy module. So we have a variable known as self verifier. Again, we are using a DSPy chain of thought. In the forward function, given an image data. So we since this requires an image, right? So we'll download the image and we'll give the binary data, and then we'll give a description and we'll give the market. So DSPy will take care of churning, talking to the again here we are using multimodal LLM, which is a again Gemini LLMs are used. So that will be used to the review the given image and the context. So a response we will get it, and from that response we'll try to get the score, and that score will be passed as a dictionary. The score, the approval status, and review feedback will be sent as a output to the again orchestrator. So prompt extractor, again we have a prompt extractor class which will do a array.search, basically break down inputs into whatever it requires, right? So it will try to break down the given input to the requirement. Basically a visual suggestion is required, so it will try to break down the visual suggestion and get the visual suggestion. If you require a campaign overview, it will try to break the text into the content of the campaign overview, and it will return the campaign overview content. So image input resolver, basically this is for downloading the image and downloading it and giving that as a DSPy image. So this class is being used, image input resolver. Basically it does the wget operation for the HTTP or HTTPS image. And a sample agent class. So here we have an image reviewer worker which is explained above. So this worker, again the task will be very similar. So given input, get the data and market. From the market you get the market final content for image generation and image input. So this will come from the prepare input class. Basically it will break down this data, the data content, right? It will break down by research, and it will provide this market final content for image generation and image input. And we'll use the image URL. The image input is embedded here, and that will be giving it to image resolver.resolve. It will provide us the image local path. It will download the image and give the local path, and then we'll give it to the self-executor worker. So what it does is, with the model context, it will do the inference. It will basically talk to the Gemini LLM, and it will provide the image data, local image path, and the image to review. And finally, if since we have downloaded the image, right, I don't have to retain it, I'll just delete it, and the result of that review data will be passed on to the agent whoever called. Basically nothing but orchestrator. The last agent is a social media campaigner. It's basically, you are a social media strategist expert. Your task is to define the target audience and distribution strategy, and for a localized campaign. So define demographics, strategize, adapt. So all these instructions are given. So again, we require a target audience, platform strategy, and posting schedules are required from this agent. So you need to provide a market, campaign content, and review feedback needs to be given, and it will provide you the social strategy as the output. So its code also remains almost same, very simple. So break it down, the input breaking down, and then talking to the agent, the LLM. So this is about the orchestrator code. So let us try to run one by one now. So let us run the demo now. I have run already this all.bash. What it does is it deletes any previously running dockers of the pods of agents, and it will rebuild the dockers again, and then it pushes to the registry, and then again removes the registration content, and again re-registers it, and again then deploys it. So that I have done already, and we can check the pods available right now. Yes, we have a marketing pods. One is a content creator, image generator, image reviewer, and orchestrator, and a social media. Totally 5 5 pods. So let me run the inference now. So I have run already one inference. So you can see here the input is a minimalistic eco-friendly bamboo electric toothbrush for Japan, Germany, and Brazil. 3 markets are given, and the product is eco-friendly bamboo electric toothbrush. So let me just show you the output first of orchestrator. Okay, so the orchestrator, it has a it will take all the available agents. So it tried to get all the available agent. We have market content creator and marketing image generator agent, content creator agent, reviewer agent, and social media agent. So it has 4 agents in the marketing category, and then given the input, which is eco-friendly, it will try to generate the stage for each market. So for Japan, okay, so let me break it down. So for Japan, we have a pipeline content creation, marketing content creator, and a task description is given. Next stage name is image generation, marketing image generator agent, and its task instruction. Next is image reviewer agent, and its task description. And then we have the last one, the social media strategist, and the media campaigner agent, and it's a task description. So this is for one of the market, which is a Japan, and then comes the Germany, and then comes the Brazil. So all the pipelines are given here. So for this pipeline, so now for these 3 markets, it will run in parallel, and those 3 the pipelines of each agent will run one after the other. So So it has run for all the 3 pipelines now. So let me just show you the output. So as it takes some time, I have run it already and I have recorded the output here. So for Japan, there is no retry happened. So this is the image 2D. So let me just show you the 2D. So yeah, this is the 2D 2D982566. So this was the image generated for Japan market. So cultural alignment score is 8 to 10. Needs revision. Visual creative exceptionally strong in converging desired brand image for Japanese market. So it has given detailed social media where it has to do. And then for Brazil, so a name has been given, a bamboo elegance, some product name has been given, and this is the image where it has 9 by 10 score, so D to 8. So here is a D to 8. So this is the image generated for the Brazil, and then comes the Germany. So for Germany image generation, here it was 7 by 10. So it is in a review history. Initially it was 7 by 10, then it gave a feedback, review feedback was available. And let me just show you this image first. 5AD0. So this was the image. For this image, maybe it would have identified something is not fine and maybe confusing and unprofessional or something like that. It has given a feedback, and then again it has regenerated the image, which is a 5081. So this was the image generated for Germany. So where it tried to match the campaign effectively. Though the cultural alignment score is 7 by 10, because of one retry, as we have given only one retry to happen. So as it gone, one retry has happened, a second retry didn't go because we have restricted for not more than one. So that's why it has stopped it there. So this is how we can, the orchestrator is talking to each and every sub agents to do the their task, and it will try to coordinate each agents, and it will try to if any retries are required or a self correction is required based on the score, you can do it in the orchestrator, and the final output will be collected by the orchestrator and given to the user. So I hope you like the video, and don't forget to subscribe and keep supporting us. Thank you.